Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter work, power and energy. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, mm, which shall be obviously helpful for your exam. So here it is told that a particle of mass m moves on a straight line with its velocity increasing with distance according to the equation v equal to alpha root x, where alpha is a constant. The total work done by all the forces applied on the particle during its displacement from x equal to 0 to x equal to d will be. The total work done by all the forces applied on the particle during, okay. So the total work done by all forces, that is equal to change in kinetic energy, we know. So that will be equal to the change in kinetic energy, which is half m v square minus half m u square. So v is the velocity at x equal to d. So that will be equal to alpha root d, and u is the velocity at x equal to 0. So that will be alpha root 0, that is equal to 0 only. So therefore work done by all forces, that is equal to, so work done by all forces equal to change in kinetic energy. It is called the work energy theorem. So therefore work done by all forces, that will be equal to half m into v square. V is alpha root d whole square. So this will be half m into alpha square d, half m alpha square d. So option C is the correct answer. Then here it is told a block is simply released from the top of an inclined plane as shown in the figure above. The maximum compression in the spring when the block hits the spring is. So here there is no friction, but here there is no friction, but here there is friction. So from here the friction will start. Till here there is no friction. From here the friction will start. So therefore we can say that here the height, the initial height, that is this is 10 sine 30. So 10 sine 30 is half. So it is 5 meters. So therefore the uh, here we will say work done by all forces equal to change in kinetic energy. So change in kinetic energy will be 0 only. So work done by all forces, here the work done by gravity plus work done by the spring plus work done by friction. That is equal to 0. Here work done by gravity, that will be equal to mgh, and work done by spring force, spring will apply force towards the left. So, and the displacement or the compression is happening towards the right. So work done by spring will be obviously negative. So that is minus half kx square. And work done by friction is also always negative, since friction will act towards the left and the displacement is towards the right. So that is minus mu mg into x, that is equal to 0. So x has been asked. So here mgh, m is 5, g we can take 10 into h is 5, minus half k is 100 into x square, minus mu is 0.5 into m, that is 5, into g, that is 10, into x is equal to 0. So therefore we can say this will be 2 5s are 10, is also 50. So this is 25. So this is 5 5s are 25, 250 minus 50x square, and minus this will be 25x, that is equal to 0. So here, from here we can take minus 25 as common. Minus 25 into, I can write 2x square plus x minus 10, that is equal to 0. So this 25 I can cancel. So then x will be equal to, so 2 tens 20, 4 5s are 20. So I can say this will be 2x square plus 5x minus 4x minus 10, that is equal to 0. So this will be x into 2x plus 5 minus 2 into 2x plus 5. So therefore x will be equal to 2 meter. So 2 meter is the maximum compression of the spring. So option D is the correct answer. Then here it is told, when kinetic energy of a body becomes 36 times of its original value, kinetic energy of a body becomes 36 times of its original value, the percentage increase in the momentum of the body will be. So as we know, kinetic energy equals to p square by 2m, where p is the momentum and m is the mass. Okay, so kinetic energy becomes 36 times. So kinetic energy is proportional to p square. So I can say K1 by K2, that is equal to P1 square by P2 square. So therefore, if kinetic energy, let's say kinetic energy 2, that is equal to 36 times of kinetic energy 1, K1. So then I can say this is K by 36 K1, that is equal to P1 square by P2 square. So this will cancel. So therefore, P2 square, that will be equal to 36 times P1 square. So it means that P2 will be 6 times P1. So it means the percentage increase in the momentum, that will be equal to P2 minus P1 by P1 into 100%. Okay. So that will be P2 is 6 P1, so 5 P1 by P1 into 100. So that is equal to 500%. So there is 500% increase. So option B is the correct answer. Then here it is told a bullet of mass 50 gram is fired with a speed of bullet is there, its mass is 50 grams, so 0.05 kg, and it is fired with initial speed u 100 meter per second on a plywood. Is a plywood, and emerges with a speed v that is 40 meter per second. The percentage loss in kinetic energy is the percentage loss in the kinetic energy, that will be equal to how much? It is initial kinetic energy minus final kinetic energy by initial kinetic energy into 100%. So this will be equal to half m u square minus half m v square by half m u square into 100%. So this will be equal to nothing but 1 minus v square by u square into 100%. So here, so it will be 1 minus 40 square by 100 square into 100%. So now this will be equal to 1 minus 40 by 100. I can write it as 2 to the 4, 2, 5, the 10. So this is 1 by 1 minus 2 by 5 whole square into 100%. So this will be equal to 4, 25 minus 4, that is 21 by 25 into 100. So that is 25 4 is 100. So 4 1 is 4, 4 2 is 8, 84%. So there is 84% loss in kinetic energy. So option C is the correct answer. Then here it is told 4 particles A, B, C, D of mass m by 2, m, 2m, and 4m have same momentum respectively. The particle with maximum kinetic energy is 4 particles A, B, C, D of mass m by 2, m, 2m, 4m have same momentum. They have same momentum. So we know that kinetic energy, that is equal to p square by 2m. So if momentum is same, then we can say that kinetic energy is inversely proportional to mass. So it means the object having least mass, it will have maximum kinetic energy. Since if m decreases, kinetic energy will increase if p is same. If the uh, m- momentum is remaining the same. So the particle having the least mass is A. A is having the least mass, so it will have the maximum kinetic energy. So option D is the correct answer. Then it is told a body is moving unidirectionally under the influence of a constant power source. Constant power source. Uh, Body is moving unidirectionally over a constant power source. Its displacement in time t is proportional to. Its displacement in time t is proportional to. So we know that power equals to work done by time or force into velocity. Force into velocity. So the power is constant. So force, as you know, it is m dv by dt into v, that is constant. Now its displacement is proportional to, that is ox. So this is constant. Let's say it is p. So v dv, that we can say that is equal to p by m into dt. So if we integrate it, then we will get v square by 2, that is equal to p by m into t. It means V that will be equal to root over 2p by m into root t. Now V is again dx by dt. So therefore I can say dx that will be equal to root over 2p by m into root t dt. Now this if we integrate, then we'll get the displacement x initial to x final, and this is 0 to t. So this will be s is equal to x final minus x initial, and that will be equal to root over 2p by m into integral root t dt, that will be t power half plus 1 by half plus 1. So this will be s will be therefore uh, 2 by 3 root over 2p by m into t power 3 by 2. So it means we can say that the displacement s is proportional to t power 3 by 2. So option B is the correct answer. Yeah, so here is told that a body of mass 50 kg, a body of mass 50 kg is lifted to a height of 20 meter from the ground in the two different ways as shown in the figures. The ratio of work done against gravity in both the respective cases will be: case 1 it is pulled straight up, case 2 it is pulled along the ramp. So the work done against gravity will be the same, since why work done against gravity equals to uh, equals to mgh. So it will depend only on the change in the height, from the ground. So therefore it is independent of the way in which the work is the way in the so it is independent of the path followed. The work done against gravity is independent of the path followed, since why it is a conservative force. So the answer will be 1 is to 1, since why the work done will be the same in case 1 and case 2. So option C is the correct answer. Then here it is told a body of mass mkg slides from rest along the curve of vertical circle from point A to point B in frictionless path. A body of mass mkg slides from rest along the curve of vertical circle from point A to B. Yeah, the the velocity at the point B is, so r has been given. R is 14 meter, g is 10 meter per second square, and root 2 is 1.4. So therefore you can say the height from the ground means, simply I will say that the work done by gravity, that is equal to the change in kinetic energy. It is equal to half mv square. Slides from rest. Okay. So here it is at rest, u equal to 0 here. So work done by gravity will be obviously mgh. h, and this is the height, that is equal to half mv square. So v square equal to 2gh. So therefore that is equal to 2 into g10 into h. H will be, this will be r plus, this is r, so this is r sine 45, so r by root 2. So r plus r by root 2. So this is 20 into r plus means 14 plus 14 by root 2. Now root 2, it is told it is 1.4. So this I can write 10. So this is 20 into 24. Is equal to 480. So v square is equal to 480. So v will be equal to root over 480. So which is 16 3s are 48 into 10. So this will be 4 into root 30. Root 30. Now root 30 will be approximately how much? So we know that is now root 30 will be obviously more than root 25. Means which is obviously more than 5 and obviously less than 6. So it will be like 5.4 approx. So 5.4 into 4, 4 is a 16, 4 5 is a 20, that is 21.6 meter per second approx. So the closest answer is option D. Option D is the closest answer. Then it is told if a rubber ball, if a rubber ball of mass m, it falls from a height h, and it rebounds up to a height h by 2, the percentage loss in the loss of total energy of the system as well as velocity of the ball before it strikes the ground respectively are. So here the percentage loss in the total energy, percentage loss in the energy, that will be equal to initial energy minus final energy by initial energy into 100%. So now initial energy, that is equal to obviously mgh, which is the gravitational potential energy, mgh minus the final gravitational potential energy is mgh by 2. Since here at the highest point the kinetic energy will be 0 only, since it will come to rest at the highest point. So this divided by mgh into 100%. So this will be equal to 1 minus 1 by 2 into 100%. So that is equal to 50%. So there is 50% loss in the energy, and the velocity of the ball before it strikes the ground. Velocity of the ball. So I will tell v square equal to u square. U is 0, u square plus 2gh. So v 2g into h by 2. Since here, from here, when it will fall down, it will fall from a height h by 2. So v will be equal to root gh. So option B is the correct answer. Then here it is told a body of mass 2 kg begins to move under the action of a time dependent force that is given by 60 I cap plus 60 square j cap Newton. Mm, the mass is 2 kg. The power developed by the force at the time t is given by the power developed by the force at the time t is given by so we know that power that is given as F dot V. Power is given as F dot V. Now from here velocity we can find. So from here acceleration that will be equal to F by m. F by m. So that will be equal to 3t I cap plus 3t square j cap meter per second square. And then velocity we can find. Velocity will be integral a dt. Integral a dt from 0 to t. And suppose we assume that it starts from rest only. So the velocity at any time that will be integral 0 to t 3t I cap plus integral 0 to t 3t square j cap. So this much meter per second. So this will be 3t square by 2. Sorry, this will be equal 3t dt. And here also dt will come. Dt I cap. So this will be 3t dt. So 3t square by 2 I cap plus is 3t cube by 3 into j cap meter per second. So this will be so velocity will be 3t square by 2 I cap plus t cube j cap. Now we have to find the power. So power equal to F dot V, force dot velocity. So F is equal to 60 I cap plus 60 square j cap. Then dot V is equal to 3t square by 2 I cap plus t cube j cap. Dot V, so this will be 60 into 3t square by 2 plus 60 into t cube. So this will be equal to 2 3 are 6. So this is 9 t cube plus 6 t power 4. So this much watt. 9 t cube plus 6 t power. Okay, this is 6 t square. So 6 t power 5. Nine t cube plus 6 t power 5 watt. So option D is the correct answer. Here it is told that a block of mass 1 kg is pushed up a surface inclined to the horizontal at an angle of 60 degree by a force 10 Newton parallel to the inclined surface as shown in the figure. When the block is pushed up by 10 meter along the inclined surface, the work done against frictional force is a block of mass 1 kg is pushed up a surface inclined to horizontal at an angle of 60 degree by a force of 10 Newton parallel to the inclined surface as shown in figure. So the work done against frictional force you have to find out. So we know that work done by all forces equal to change in kinetic energy. So now we can say work done against gravity so here gravity is acting and this force is acting, work done by the applied force plus work done by friction, that is equal to 0. Since by change in kinetic energy will be 0 when when it is pushed up by 10 meter along the inclined surface. So work done by gravity, it is pushed up, so work done by gravity will be negative since gravity is acting downwards and it is going upwards, mg is acting downwards. So this will be minus mgh and work done by this force that will be equal to plus F into x plus work done by friction. Now friction is doing negative work obviously, so it is minus mu mg cos theta since n, this is theta which is 60 degree. So this will be mg cos theta, this is mg sin theta. So hence it means that work done by the friction, that is minus mu mg cos theta into x. Now it is going upwards by a length 10 meter, 10 meter, which is equal to x actually, and here this is angle theta. So 10 cos theta is this, and this is 10 sin theta, which is equal to the h height. So theta is 60 degree. So h will be equal to 10 into root 3 by 2, which is equal to 5 root 3 meters. And this length x, that will be equal to 10 cos 60, that is half, so that is 5 meters. So this is equal to 0. So it means that minus m, that is 1, g is 10 into h, that is 5 root 3 plus f is 10 into x, that is 10 minus mu is given 0.1 into m, that is 1 into g 10 into x cos theta. This is x cos theta, that is 5, that is equal to 0. Okay. Now here work done against frictional force. Now the work done against frictional force, that will be obviously mu mg x cos theta, which is the work done against frictional force. So which will be obviously 0.1 into 1 into 10 into 5, which is 5 joule. So option B is the correct answer. Here it is told a particle is placed at the point A of a frictionless track ABC. A particle is placed at the point A of a frictionless track ABC as shown in the figure. It is gently pushed towards the right. The speed of the particle when it reaches the point B is. A particle is placed at the point A of a frictionless track. ABC is shown in the figure. It is gently pushed towards the right. The speed of the particle when it reaches the point B is. So here we will say that work done by gravity, that is equal to the change in kinetic energy, since why there is no friction here. So here work done by gravity, that is the change in the height, where this will be 0.5 meters. So mghm, okay, speed is asked. So mgh, h is this, is equal to half mv square. Since here it is at rest only, it is, since it is gently pushed, it is asked. So m will cancel, so v square equal to 2gh. So v square will be equal to 2 into g, that is 10, into h, that is 0.5. So v square equal to 10, 10. So v will be equal to root 10 meter per second. So when it will reach point B, the speed will be root 10 meter per second. So option C is the correct answer. And here it is told a bob of mass m is suspended. A bob of mass m is suspended by a light string of length L. A light string of length L. Light string of length L. It is imparted a minimum horizontal velocity at the lowest point A. It's imparted a minimum horizontal velocity at the lowest point A. Such that it just completes half circle, uh, reaching the topmost position B. Circle reaching the topmost position B. The ratio of kinetic energies at KEA by KEB, that is. So minimum horizontal velocity it has to give. So it means at the topmost point, the tension should be 0. So here at point B, I should say, at point B, mg only that will provide the necessary centripetal force, half mvb square. So it means vb will be equal to root, yeah, f equal to, sorry, that is mv square by l, v square by l. So vb equal to root gl, and va, so that will be loss in kinetic energy equal to gain in potential energy. So I will say half mva square minus half mvb square, that is equal to mg into 2l, since the gain in the height is 2l from A to B. So here m will cancel out. So I can say va square, that is equal to vb square plus 4gl. So vb square is gl, so va is root 5gl. So therefore now we have to find the ratio of kinetic energy at point A by kinetic energy at point B. So kinetic energy at point A, that is equal to half mva square divided by half mvb square. So half m will cancel. So va square by vb square. Now va square, that will be 5gl, and vb square, that is equal to gl. So the ratio is 5 is to 1. 5 is to 1. So option A is the correct answer. Then here it is told a block of mass 100 kg slides over a distance of 10 meter over a horizontal surface. If the coefficient of friction in between the surface is 0.4, then the work done against friction is. So there is a mass m, a block of mass m, which is 100 kg. It slides over a distance of 10 meters, a distance of 10 meters along the horizontal surface, the coefficient of friction is 0.4. Then the work done against the friction, that will be how much? What will be the work done against friction? So that is equal to, that will be mu mg into d. Since here the normal reaction will be same as mg, so that will be mu mg into d here. So now mu, that is equal to 0.4 into m. M is 100 kg. Mu g is 10 into d is 10. So this will be 4000 joule. 4000 joule. So the work done against friction, that will be 4000 joules. So option D is the correct answer. Then here it is told the potential energy function in joule of a particle in a region of space is given as u equal to 2x square plus 3y square, 3y cube plus 2z. Here x, y, and z are in meters. The magnitude of x component of force in Newton acting on the particle at point P. The magnitude of x component of the force acting on the particle we have to find at the point P, that is 1, 2, 3 uh, meters is. So the x component of force, so x component of force, that will be equal to minus dou u by dou x at the point P, that is at x equal to 1, 2, 3. So now dou u by dou x, so that will be equal to, so here x is taken only as the variable and the remaining, and y and z are taken as constants. So this will be equal to 4x. V by dou x is 4x. And so at x equal to 1, at x equal to 1, dou u by dou x value, that will be equal to 4. So therefore the x component of the force, that is minus 4 Newton. Only magnitude is asked, so we can take only the positive sign, that is 4 Newton. So 4 is the correct answer, option A. Here it is told a bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 centimeter. A bullet is there. Bullet is fired into a fixed target, fixed target, and it loses 1/3 of its velocity. So initially, if the velocity is u, then after after traveling 4 centimeter, it loses 1/3 of its velocity. So here the velocity, let's say v1, that is equal to 2u by 3. Since 1/3 has been lost, it penetrates further by d millimeter. D millimeter, it means it is d into 10 power minus 3 meters before coming to rest. So here, suppose it comes to rest, v equal to 0. The value of d is, so here it is told, so here we can say v square equal to u square minus 2a into s. Since here the suppose we should assume that the target will cause a fixed retardation, since it will apply the constant retarding force, assuming that the retardation is constant, or assuming that the retarding force is constant. So now we can say v square v1 square u square by 2as, and here we can say v1, that is 2u by 3, 2u by 3 whole square, that is equal to u square minus 2a into s is 4 centimeters, so 4 by 100 meters. So now we can say that this will be 4u square, u square minus 4u square by 9, that is equal to 0.08a. So this is equal to 5u square by 9, that is equal to 8a by 100. 2 4s are 8, 2 5s are 10. So you can say 4 2s are 8, 4 25s are 100. So it means 2a, that is equal to 25 into 5u square by 9, means 2a, that is equal to 125 u square by 9. So it is twice of the retardation that is being caused. Now it is told that after it travels more, it penetrates further by d into 10 power minus 3 meter, then it will come to rest. So now therefore I can say that here also v square equal to v1 square minus 2a into s dash, suppose. So v square, that is 0. So 0 square, that is equal to v1 square, that is 2u by 3. So 2u by 3. Okay, so it is 2u by 3 whole square minus 2a into s dash. S dash is d into 10 power minus 3. Value of d has been asked. So from here you can say that 4u square by 9, that is equal to 2a into d into 10 power minus 3. So therefore I can say 4u square by 9, that is equal to 2a which we have found. 2a is 125 u square by 9 is into d into 10 power minus 3. So u square by 9, u square by 9 will get cancelled. So d will be equal to 4 yeah, 4 by 125 into 10 power minus 3. So therefore d will be equal to 4 by 125 into 1000. 125 8 is a 1000. So it means d will be equal to 32. D will be equal to 32. So option B is the correct answer. A force displaces a body from x equal to 2 meter to x equal to 4 meters. Work done by this force is dash joule. Force displaces. So okay. So work done by this force dash joule. So when we have a variable force, then we in order to find the work done, we have to do integration. Means we have to do integral f dx from x initial to x final. Here x initial is 2, x final is 4. So therefore we will do 3x square plus 2x minus 5 into dx integral from 2 to 4. So this will be 3x square integral is x cube, 3 into x square by yeah. It is integral 3x square dx 2 to 4 plus this is 2x integral integral 2x dx from 2 to 4 minus 5 integral dx from 2 to 4. So this will be equal to x cube by 3. So x cube, it will go from 2 to 4 plus will be 2x square by 2, that is x square, and that will go from 2 to 4 minus 5x, and that will go from 2 to 4. So this will be 4 cube. So for the 16, 64, 64 minus 8 plus this will be 4 square 16 minus 4, then minus this is 5 into 4 minus 2. So this will be equal to 64 minus 8, that is equal to 56 plus 16 minus 4, that is equal to 12 minus 5 into 2, that is equal to 10. So 56 plus 2, that is equal to 58 joule. 58 joule. Work done by this force is 58 joule. Then here it is told the ratios of powers of two motors is 3 root x by root x plus 1 that are capable of raising 300 kg of water in 5 minutes and 50 kg water in 2 minutes respectively from a well of 100-meter deep. The value of x will be. Okay, so here so one is capable of raising 300 kg water in 5 minutes, so it will be mgh mg from a well 100-meter deep, so it is 100 mg 10 into h is 100 h by t is 5 minutes, so 5 into 60 seconds. Since we know that power, that is equal to work done by time, so work done is equal to mgh by t, that we have to use. So this by, so the ratio of their powers, that is power of A by power of B, that is equal to mgh by t by mgh, that is 50 into 10 into 100 mgh by t is 2 minutes, so it is 2 into 60 seconds, and that is equal to 3 root x by root x plus 1. So x we have to find out. Now 60 60 will cancel, 100 100 will cancel, 10 10 will cancel. Now then here we got that 5 6 is 30, so this is, and this is 2 25 is 50, so 60 by 25, that is equal to 3 root x by root x plus 1. So 3 with 3 we can cancel out. 3 20s are. So from here you can say 20 root x plus 20, that is equal to 25 root x. So therefore 5 root x, that is equal to 20. So root x equal to 4. X will be equal to 16. So option A is the correct answer. Then here it is told two bodies are having kinetic energies in the ratio 16:9. If they have same linear momentum, the ratio of their masses respectively is. So we know that kinetic energy equal to p square by 2m. So if the ratio, if they have the same linear momentum, so if I tell that the momentum p is the same, then we can say kinetic energy is inversely proportional to the mass. So it means that kinetic energy 1 by kinetic energy 2, that will be equal to m2 by m1, and that is equal to 16 by 9, which has been told that two bodies are having kinetic energies in the ratio 16:9. So therefore m1 by m2, that will be obviously 9 by 16. So the ratio of their masses should be 9:16. So option C is the correct answer. Then here it is told a truck and a car m- moving with the same kinetic energy are brought to rest. So here it is told a truck, a car and a truck, that is a truck and a car that is moving with the same kinetic energy. So their kinetic energy is same, K1 equal to K2, are brought to rest by applying brakes which provide equal retarding forces. Both come to rest to in equal distance. So we know that the change in kinetic energy equal to work done by the frictional force in this case. So work done by frictional force, that is equal to F into x, where F is the retarding force into x is the displacement. So if the change in kinetic energy is same and if the force is also same, then they will obviously come to rest in equal distance only. So x also will be same. So statement 1 is true. Statement 1 is obviously true. Then in statement 2 it is told a car moving towards the east, a car moving towards the east uh, takes a turn and moves towards the north. The speed remains unchanged. The acceleration of the car is 0. But but it is wrong, since why? Acceleration we know that is change in velocity by time. So here the, even if the magnitude of velocity remains unchanged, the but the velocity vector will obviously change, since why the direction of motion of the car has changed. So here the acceleration, it would be like if I take the east as I cap and the north as j cap, then I will say v is uh, let's say the car is moving with a velocity v, so it will be v j cap minus v I cap by t. So it's magnitude of the acceleration, if we want to find, that will be obviously v root 2 by t. Acceleration of the car is 0, the speed remains unchanged. So statement 2 is false. 2 is false. So 1 is correct, but 2 is incorrect. So option B is the correct answer. Then here it is told a bullet of mass 0.1 kg moving horizontally with a speed 400 meter per second. It hits a wooden block. Hits a wooden block. Wooden block. It hits a wooden block of mass 3.9 kg. 3.9 kg kept on a horizontal rough surface. Let's say we take it as capital M. Horizontal rough surface. It is rough. The uh, bullet gets embedded into the block. The bullet gets embedded into the block and moves 20 meter before coming to rest. The bullet gets embedded into the block and moves 20 meter before coming to rest. The coefficient of friction in between the block and the surface is so the bullet gets embedded. It moves 20 meter for coming to rest. So the bullet and the block will move together. So the bullet which is embedded into the block, that will move along with the block on the surface and move 20 meter before coming to rest. And so the let's say the coefficient of friction is mu. So therefore I will tell the frictional force that will be equal to mu m plus m into g. So that will be equal to mu into m, that is 3.9 plus 0.1 into g. G is 10, so that is equal to this 440 g 40 mu. So therefore we can say work done by friction, that is equal to the loss in kinetic energy. So it is equal to half m u square. So work done by friction, that is equal to change in kinetic energy. So it is minus mu square. So it is minus mu into 40 friction into x, that is 20, that is equal to minus half mu square. M is so actually this will be half m. M is the mass of the bullet. Since only the bullet is having an initial speed, but the block is initially kept at rest only. So half into m, that is 0.1 into u square. U is 400. 400 into 400. So 2 2's 4. So this is also 20. This I can cancel, and with 40 or 40 tens 0.1 400 moves 20 meters. So mu is coming 10, but option is not there. This will not be 400 meter per second, it will be 40 meter per second. Zero 0.1 into 40 into 40 divided by 2 into m plus m, that is 4 into 10 into x is 20 meter. So 4 tens of 40, 2 20s of 40. So this is so mu is coming 0.1. There is no such option here. So none of the options are correct. Then here it is told, identify the correct statements from the following. Work done by a man in lifting a bucket out of a well by means of a rope tied to the bucket is negative. Work done by a man in lifting a bucket out of a well tied by means of a rope tied to the bucket is negative. No, that is wrong. Work done by gravity will be negative, but work done by the man, that will be positive only. Since he is applying force upwards, so he is doing positive work. So A is wrong. Work done by gravitational force in lifting a bucket out of a well by rope tied to the bucket is negative. Yeah, this is correct, since gravitational force is acting downwards, and the weight and the bucket is lifted upwards. So work done is negative, since the force is acting opposite to the displacement. Work done by friction on a body sliding down an inclined plane is positive, but that is wrong, since why work done by friction is always negative, since friction always acts opposite to the displacement of the body. Then work done by an applied force on a body, work done by an applied force on a body moving on a rough horizontal surface, applied force is acting with uniform velocity is 0. So applied force should be equal and opposite to the frictional force. So it is moving with a uniform velocity, so it means the displacement is not 0 and force is also not 0, means the applied force is not 0. Therefore, the work done is also not 0. So statement D is also wrong. Work done by the air resistance on an oscillating pendulum is negative. Work done by the air resistance work done by the air resistance on an oscillating pendulum. So one pendulum is oscillating to and fro. So work done by the air resistance. So air resistance is acting opposite to the velocity. So work done will be negative. So E is also the correct statement. So only B and E are correct statements. So option D is the correct answer. And here it is told a stone is projected at an angle 30 degrees to the horizontal. Is projected 30 degrees to the horizontal. The ratio of the kinetic energy of the stone the ratio of the kinetic energy of the stone at a point of projection to its kinetic energy at the highest point. So kinetic energy at the highest point, let it be K2. So we have to find K1 by K2. So the kinetic energy at the point of projection, that is half mu square, and at the highest point the velocity is u cos 30 degree only, so which is u root 3 by 2. So that will be half mv square. So this will be equal to u square by v square. So that is u square by u square 3 by 4. U square cancel, so that will be 4 by 3. So therefore the required ratio is 4:3 is the ratio. So option C is the correct answer. Then here it is told a block of mass 10 kg is moving along the x-axis. Block of mass 10 kg is moving along the x-axis under the action of the force F equal to 5x Newton. 5x Newton. The work done by the force in moving the block from x equal to 2 meters to x equal to 4 meters will be work done. So work done here, the force is a variable force, it is not a constant force. So therefore we have to integrate. So work done equal to F dot integral F dx. So x will go from 2 to 4. So F is equal to 5x dx, and it will go from 2 to 4. So therefore 5 into this will be x square by 2, and that will go from 2 to 4. So this will be 5 by 2 into 4 square minus 2 square. So this will be 5 by 2 into 16 minus 4. So this is equal to 12. So 5 by 2 into 12. So 2 6 are 12, 5 6 are 30 joule. So 30 joule is the correct answer. A car, then it is told a car accelerates from rest. So V initial V naught is 0 and V final velocity is u. So there is some acceleration. So car accelerates from 0 to u, and the energy spent in this process is E joule. The energy spent is E joule. Energy spent E joule. So the energy required to accelerate the car from u meter per second to 2u meter per second. Car, so it will be accelerated to v1, that is 2u meter per second. Then what is the energy required? Energy required. That will be how much? And that is given as ne joule. Ne joule. So then n will be how much? So now the energy required, that is equal to the gain in kinetic energy. That is equal to the gain in kinetic energy. So equal to half mu square. And here the energy required, that is equal to the gain in kinetic energy. That is Ke final minus Ke initial. So there the energy required, that is equal to Ne joule. So Ne, that is equal to Ke final, that is half m v1 square, that is half m into 2u square minus half m into u square. So this will be equal to, so Ne, that is equal to, that is half mu square, I can take as common, and this will be 4 minus 1. So that is 3. So it is 3 times of half mu square, which is 3 times of E. Therefore, Ne equal to 3E. So therefore, N equal to 3. So the value of N is 3. So it will, so the energy required to accelerate it from U to 2U, that is 3 times of the energy required to accelerate it from rest to U. When it is told to maintain a speed of 80 kilometer per hour by a bus, to maintain a speed v which is 80 kilometer per hour by a bus having mass 500 kg on a plain road, on a plain rough road for 4 kilometer distance, for 4 kilometer distance, that is s 4 kilometer, the work done by the engine of the bus will be, work done by the engine of the bus will be, the coefficient of friction between the tire of bus and the road is 0.04. So then here, so therefore the frictional force will be equal to the applied force by the engine. Since why? Then only it will be able to move with a constant velocity. So the frictional force, that is equal to mu mg, since the normal reaction is same as mg. So now therefore the applied force, that is also equal to mu mg, but it is in the opposite direction. Now therefore the work done by the engine of the bus, that is equal to the applied force by the engine into the uh, uh, displacement. So applied force, that is mu mg. So mu is 0.04 to m, which is 500, into g, that is 10, into the displacement, that is 4 kilometer. It means 4 into 10 power 3 meters. So this much joule it will come. So this will be equal to 4 for the 16. So it is 0.16 into 1000, that is 160 into 5000. So this is equal to 0.56 38 800 kilojoule. That is 800 kilojoule. And here it is told a block of mass 5 kg, mass is 5 kg. It starting from rest, pulled up on a smooth inclined plane, making an angle 30 degree with the horizontal, 30 degree with the horizontal, and with an effective acceleration, uh, it should be effective with an effective acceleration of 1 meter per second square. The power delivered by the pulling force at t equal to 10 seconds from the start is. Okay, so here we have the inclined plane, which is a smooth inclined plane. Smooth, there is no friction. It is making an angle 30° with the horizontal, and the block having mass 5 kg, it is pulled upwards with an effective acceleration of 1 meter per second square. The power delivered by the pulling force at time t equal to 10 seconds from the start. The t equal to 10 seconds from the start is dash watts. So that the power delivered at 10 seconds that we have to find out is G equals to 10 meter per second square. Calculate the nearest integer value. So there is no frictional force, but so F, yeah, mg is acting, mg, and then this will be mg, this will be theta equal to 30°. This is mg cos theta, this is mg sin theta. This is the normal reaction, and there is no friction. So therefore I can say the net force, that is F minus mg sin theta, that is equal to m into a. So therefore the force that will be equal to m into a plus g sin theta, and then the applied force, so the instantaneous power we have to find. Instantaneous power is given as force into the velocity, force into velocity. Now we can say, since the acceleration is constant, so then acceleration we can say that is acceleration is 1 meter per second square. So I can say v will be equal to u plus at. So v that will be equal to u, that is 0, since it is told it starts from rest only, plus acceleration, that is 1, into time, that is 10 seconds. So it means v will be equal to 10 meter per second. 10 meter per second. So therefore the power delivered, the power delivered by the pulling force, that will be equal to m, means 5 into a, that is 1 plus g sin theta. So g into sin theta, that is half, sin 30 is half. So 2 5s are 10, 5 plus 1 6, 6 5 is 30 Newton. So the power delivered is F into V. So that means force is 30 Newton into 10. So that will be equal to 300 watts. So 300 watt is the answer. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter work, power and energy. So still any doubts, if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos. And also please install our Sapience education application, where we shall upload important questions on the previous year JEE Mains exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.